वेलकम फ्रेंड्स, स्वागत है आपका मेरे चैनल एग्ज़ाम ऑब्जेक्टिव में। आज हम थर्मोडायनेमिक्स सीरीज़ 1000 प्लस एमसीक्यू के सेट 4 लेके आए हैं। जिन भी दोस्तों ने सेट 1 2 3 मिस किए हैं वो डिस्क्रिप्शन में जाकर लिंक पे क्लिक करके वो वीडियो भी देख सकते हैं। तो आइए शुरू करते हैं आज का टॉपिक थर्मोडायनेमिक सीरीज 1000 प्लस एमसीक्यू सेट 4। तो इसमें हम 90 क्वेश्चन पे पहुंचे थे। तो क्वेश्चन 91 है, द गैस इन कूलिंग चैम्बर of a closed cycle gas turbine is cooled at, we have option A constant volume, B constant temperature, option C constant pressure, option D is none of these. So its answer is C, constant pressure. The gas in cooling chamber of a closed cycle gas turbine is cooled at constant pressure. Next question is, an open cycle gas turbine works on option A Carnot cycle, option B Otto cycle, option C Joule cycle, and option D we have Stirling cycle. So its answer is Joule cycle. An open cycle gas turbine works on Joule cycle. So answer is C, Joule cycle. Next question is, an open cycle gas turbine plants, we have four options given. The indirect heat exchanger and cooler is avoided. Option B, direct combustion system is used. Option C, a condenser is used. Option D is all of the above. So its answer is all of the above. In open cycle gas turbine plant, the indirect heat exchanger and cooler is avoided, direct combustion system is used, and a condenser is used. Next question is, reheating in gas turbine, we have four options. Option A increases the thermal efficiency, option B increases the compressor work, option C increases the turbine work, and option D is decreases the thermal efficiency. So we have to tell reheating in gas turbine what happens to efficiency. Increasing the thermal efficiency, that is option A is the answer of this question. Reheating in a gas turbine increases the thermal efficiency. Next question is, a cycle consisting two constant pressure and two isentropic processes is known as, we have four options, Carnot cycle, option B Stirling cycle, option C Otto cycle, option D is none of the above. So its question is none of the above. Next question is, select the wrong statement. We have four options given. A Joule cycle consists two constant volume and two isentropic processes. Option B. An Otto cycle consists of two constant volume and two isentropic processes. Option C. An Ericsson cycle consists of two constant pressure and two isothermal process. Option D is all of the above. So its answer must be A. That is, a Joule cycle consists of two constant volume and two isentropic processes is the correct statement, and other statements are wrong. Next question is, which of the following is correct statement? We have to find out which statement is correct. We have four statements. Statement A, for a given compression ratio, both Otto and diesel cycle have the same efficiency. Option B, for a given compression ratio, Otto cycle is more efficient than diesel cycle. Option C, for a given compression ratio, diesel cycle is more efficient than Otto cycle, and option D we have the efficiency of Otto or diesel cycle have nothing to do with compression ratio. So its answer is B, that is for a given compression ratio, Otto cycle is more efficient than diesel cycle. The answer is B. Next question. When cutoff ratio is blank, the efficiency of diesel cycle approaches to Otto cycle efficiency. So we have four options. Option A 0, option B 1/5, option C 4 divided by 5, and option D is 1. So its answer is A, that is 0. When cutoff ratio is 0, the efficiency of diesel cycle approaches to the Otto cycle efficiency. Let's move to the next question. Which of the following statement is wrong? We have to find out wrong statement from the following. We have four statements here. Option A is the closed cycle. Gas turbine plants are external combustion plants. Option B, in the closed cycle gas turbine, the pressure range depends upon the atmospheric pressure. Option C, the advantage of efficient internal combustion is eliminated as the closed cycle has an external surface. Option D, in open cycle gas turbine, atmosphere acts as a sink and no coolant is required. So its answer is wrong statement is that is B. In the closed cycle gas turbine, the pressure range depends upon the atmospheric pressure. So this is the wrong statement. Let's move to the next question. The work ratio of a gas turbine plant is given by option A, net work output divided by work done by the turbine. Option B, net work output divided by heat supplied. Option C, actual temperature drop divided by isentropic temperature drop. Option D, isentropic increase in temperature divided by actual increase in temperature. So its answer is A, that is net work output divided by work done by the turbine is the work ratio. Now next question is, the efficiency of a gas turbine is given by, we have four options. Option A, net work output divided by work done by the turbine. Option B, net work output divided by heat supplied. Option C, actual temperature drop divided by isentropic temperature drop. Option D, isentropic increase in temperature divided by actual increase in temperature. So its answer is B. The efficiency of gas turbine is given by net work output divided by heat supplied. So answer is B. Next question. The work ratio of simple gas turbines cycle depends upon option A, maximum cycle temperature, B, minimum cycle temperature, C, pressure ratio, option D, all of these. So we have the answer all of the. The work ratio of simple gas turbine cycle depends upon maximum cycle temperature, minimum cycle temperature, and pressure ratio. All of the above are the answer. Let's move to the next question. In an idle gas turbine plant, it is assumed that the compression and expansion processes are, we have four options, isothermal, option B isentropic, option C polytropic, and option D is none of these. So its answer is isentropic. In an ideal gas turbine plant, it is assumed
Next
that
question
the
is
compression and expansion
the efficiency
and work ratio of a simple gas turbine cycle are option A low, option B very low, option C high, option D very high. So answer is very low. The efficiency and work ratio of simple gas turbine cycle are very low. The option is B. Next question is the thermal efficiency of an ideal gas turbine plant is given by, we have four options. Option A, R raised to the power gamma minus 1. Option B, 1 minus R raised to the power gamma minus 1. Option C, 1 minus 1 divided by R whole raised to the power gamma divided by gamma minus 1. And option D, 1 minus 1 divided by R whole raised to the power gamma minus 1 divided by gamma. So its answer is D, that is 1 minus 1 divided by R whole raised to the power gamma minus 1 divided by gamma, where R is the compression ratio, as you all know. अगर आपको ये क्वेश्चंस थोड़े से भी इम्पोर्टेंट लग रहे हों तो कृपया मेरे वीडियो को लाइक और शेयर ज़रूर करें और सब्सक्राइब करना ना भूलें. चलिए नेक्स्ट क्वेश्चन की ओर. Which of the following is the correct statement? We have to find out correct statement. So we have the four statements. Statement A, all the reversible engines have the same efficiency. Option B, all the reversible and irreversible engines have the same efficiency. Option C, irreversible engines have maximum efficiency. And option D is all engines are designed as reversible in order to obtain maximum efficiency. So its answer is C. Correct statement is irreversible engines have maximum efficiency. Next question. A cycle consisting two isothermal and two isentropic processes is known as, we have four options. Option A, Carnot. Option B, Stirling. Option C, Ericsson cycle. Option D is Joule cycle. So answer is Carnot cycle. Carnot cycle consists of two isothermal and two isentropic यानी कि constant entropy processes. Next question. For the constant pressure and heat input, the air standard efficiency of gas power cycle is in the order of, we have four options: Joule cycle, then diesel cycle, then Otto cycle. Option B, Otto cycle, diesel cycle, then Joule cycle. Option C, Joule cycle, Otto cycle, and then diesel cycle. And option D is diesel cycle, Otto cycle, and then Joule cycle. So its answer is A, Joule cycle, diesel cycle, and then Otto cycle. Next question. The compression ratio of diesel engines is, this is the most popular question and the most basic question. The compression ratio for the diesel engine is C, that is 15 to 20. This is the compression ratio for diesel engine. And next question is the compression ratio of petrol engine is, that is 5 to 8. Question number B is the answer. This is the most basic question of the thermodynamics. Let's move to the next question. Diesel cycle consists of blank processes. So we have four options. Option A, two constant volume and two isentropic. Option B, two constant pressure and two isentropic. Option C, two constant volume and two isothermal. And option D is one constant pressure, one constant volume, and two isentropic processes. So its answer is D, one constant pressure, one constant volume, and two isentropic processes. You can see graph of this cycle of this process for diesel cycle also. Next question is the air standard efficiency of an Otto cycle is given by, we have four options: 1 minus r raised to the power gamma minus 1, B 1 plus r raised to the power gamma minus 1, C 1 minus 1 divided by r raised to the power gamma minus 1, and D 1 minus 1 r raised to the power gamma minus 1. So option is C. 1 minus 1 divided by r raised to the power, r raised to the power, not whole, only r raised to the power gamma minus 1, where r is the compression ratio. Next question is, the efficiency of Ericsson cycle is blank Carnot cycle. Greater than Carnot cycle, B less than Carnot cycle, C equal to, D none of these. So its answer is C, that is equal to the Carnot cycle. The efficiency of Ericsson cycle is equal to the Carnot cycle. So option is C, equal to. Next question, which is incorrect? These words are most important to remember during the examination, because most of the people get confused in these words like correct, incorrect, wrong, right, accept, etc. Which is incorrect statement about Carnot cycle? We have four statements. It is used as the alternate standard of comparison of all heat engines. Option B, all the heat engines are based on Carnot cycle. Option C, it provides concept of maximizing work output between the two temperature limits. Option D is all of the above. So its answer is all heat engines are based on Carnot cycle is the incorrect statement, because we have Carnot cycle is the reversible cycle, and in this universe none of the process is reversible, all the processes are irreversible. There is something heat loss. So next question is, the efficiency of Carnot cycle is, this is the most basic question also. We have four options. Option A, T1 divided by T2. Sorry, this is the misspelled here. This is T2. T1 is the low temperature. T2 is the high temperature. B, 1 minus T1 divided by T2. There must be some correction to do. This must be T2 divided by T1, and this is T1 divided by T2, and option C is 1 minus T2 divided by T1, and option D is 1 plus T1 divided by T2. So answer is C, that is 1 minus temperature T2 divided by temperature T1. As we know, we have already learned at the degree college, that this is source, this is sink, this is temperature T2, this is temperature T1, this is the higher temperature, this is the lower temperature, and somewhere like that. Next question is, the main cause for irreversibility is, as I said, I think all the processes are irreversible. And what are the causes for the irreversible? That is these are a mechanical and fluid friction. It can be, yes. Unrestricted expansion. This could be heat transfer with a finite temperature difference. This could be also. So we will check which one is the correct answer. D, all of the above are the correct answers. Main cause for the irreversibility. So let's move to the next question. In an irreversible process, there is also a common question: loss of heat, no loss of heat, gain of heat, and no gain of heat. This is loss of heat. In reversible process, there is always a loss of heat. Next question is, the ratio of molar specific heats for monoatomic gas is, we have four options: 1, option B 1.4, option C 1.67, option D is 1.87. So its answer must be C, 1.67. The ratio of molar specific heats for monoatomic gas is 1.67. Next question: which of the following statement is correct? Also focus on this word correct. Which of the following statement is correct? We have four statements. First statement is, the increase in entropy is obtained from a given quantity of heat at a low temperature. Option B, the change in entropy may be regarded as a measure of the rate of the availability of or unavailability of heat, or unavailability of heat for transformation into work. Option C, the entropy represents the maximum amount of work obtainable per degree drop in temperature, and all of the above. So its answer is all of the above statements are correct. And next question and the last question of this set is question number 120. If closed integral of delta Q divided by T is greater than 0, then the cycle process is very important and basic question. Option A reversible, option B irreversible, option C impossible, option D is none of the above. So its answer is impossible. So this was the फोर्थ सेट ऑफ द थर्मोडायनेमिक सीरीज 1000 प्लस एमसीक्यू। अगर आप लोगों को ये वीडियो थोड़ा सा भी पसंद आया हो तो कृपया लाइक करें और कमेंट करें और मेरे चैनल को सब्सक्राइब और बेल आइकन को दबाना बिल्कुल ना भूलें। थैंक यू वेरी मच।